So we talked last week about how to factor, right? All right, I'm going to see what you guys remember about factoring. So let's pick up with number 7 on your notes. It's 4y squared minus 11y plus 6. Somebody tell me, what's the first thing you should look for when you're trying to factor? I think it should be number 7 on your notes on the last page. Oh, number 6 we need to do? Okay, sorry. Let's back up to number 6 then. Or it's number 6 on your notes, which you say.
Yeah, keep going.
Keep going back? Okay, so we need to do number 6. But we did do number 5. Okay, so we'll start with number 6. So we got 6p squared plus 19p plus 10. So talk to me about what you remember. First thing to do with factoring. Yeah, look for a greatest common factor. So do you see one in 6p squared plus 19p plus 10? Just one. So I don't have a common factor that I can bring out. So now what am I going to do? A times C. Awesome. All right, what is A times C? 6 times 10, which is 60. Okay, now you tell me. I need a pair of numbers that will do what to give me 60? Multiply. Good job. And if it is a positive 60, what do I know about signs? Are they going to be the same or are they going to be different? They're going to be the same, and they're going to be which sign? Why is it going to be plus? Very good. I go back and I check B, and B is positive 19. So that tells me that not only will my numbers multiply to give me positive 60, they got to add to give me positive 19. That's why they both got to be positive, right? Okay, so what positive numbers could possibly do that?
15 and 4.
All right, I've got a recommendation to consider 15 and 4. We know when we start thinking about things that would multiply to give us 60, 1 times 60, that's not going to add to give me 19. I know they need to be closer, and I can start going through the list. And this is where you can take your calculator and do 60 divided by, and do 60 divided by 2. You get 30. That's too big. 2 plus 30. 60 divided by 3, 20. 3 plus 20 is 23. It's closer, but it's not there yet. 4 and 15 is the right pair. Now, what will I do with this 4 and 15? There you go. I'm going to replace my B. And what will I write instead of 19p?
4p.
There you go. Plus 15p plus 4p. Very good. Plus 10. Because I'm not changing anything other than I want to write the B as 2 terms. And it's got to mean the same thing as 19p. But I'm carefully figuring out which 2 numbers I'm going to combine in order to get the 19p so that this is going to factor 2 at a time. So when you look at the first pair, what would be my GCF?
3p.
Excellent, 3p. And inside parentheses, I would get what?
P and plus 5.
Well, 3p times what gives me 6p squared? 2p, right? Match my sign plus 3p times what gives me 15p? 5. Close my parentheses. How do I make sure I really did that part right? Yeah, if I distribute, I can double check to see that it gives me back 6p squared plus 15p. 3p times 2p is 6p squared. 3p times 5 is 15p. So far, so good. Now what do I do? I am going to look at the next pair, but what should I write down before I forget? Good. Bring down the next sign, which is a plus. And now when I look at the last pair, what's my GCF? 2. And what will I get inside the parentheses? 2p plus 5, right? And again, if I distribute, I'm going to see that I get back the 4p plus 10. Now, you tell me, what do I do next? Excellent. I should notice this parentheses and this parentheses is the same, right? That means I have a new common factor. And 2p plus 5 is my new common factor. Inside the other parentheses will go what? 3p plus 2. And if I've done this correctly, what would I be able to do to check to see that it's right? Use FOIL or the box to multiply these two parentheses back together and make sure it does give me 6p squared plus 19p plus 10. All right, give me a quick show of hands. How many of you say, I think I'm getting this. I'm feeling a lot better about factoring. Okay, how many of you say, I still need some more practice? Okay, so we're going to continue to practice. I want you, though, to see if you would be able to do number 7. So I'm going to give you a second to see what happens if you try to start on it. Okay, so we were just looking at this, and you guys have told me that you think the right pair is -3 and -8, because when you did A times C, 4 times 6 was 24. Which meant if I'm multiplying and I get a positive, I know the signs are the same. My B was a -11, and you guys said that means they both had to be negative, and you said the right pair is -8 and -3. Okay, so pretty much we got that far. Now, where does this -8 and -3 need to go? Why do we need it? We're going to do what with it? Replace B. So if we come over here, you wrote 4y squared minus 8y minus 3y plus 6, correct? Are we together? You might have put the minus 3y first and the minus 8y second, and that's okay if you did. Doesn't matter on that. Talk to me about what happens in the next step. What did you do with that first pair? Okay. And what did you say was your common factor? 4y. If you put minus 8y first, then you would have 4y here. Inside the parentheses, you would have what? 4y times y gives me 4y squared. Then what else? Minus 2, because 4y times -2 is how I get -8y. Okay, if you put the minus 3y first, this step looks different on your paper, and it's okay. We should end up with the same parentheses at the end. We just, our in-between step will look different. Now what would need to be written down? The minus sign. And when you look at this pair, what would be your GCF? 3. So if I factor out -3 is the GCF, what's going to go inside the parentheses here? -3 times what gives you -3y? Y. Here's where you got to be careful on signs. -3 times what gives you +6. -2. Good job. And because these parentheses match, that tells me I can use that as my new common factor, y minus 2. What's going to go in my other parentheses? 4y minus 3. And if I use the box to double check and multiply back together, this should give me 4y squared minus 11y plus 6. How many of you got it right? Okay, so that's quite a few of you that you've gotten the hang of this. We're going to keep practicing. But that's factoring using the AC method. If we have 3 terms, a trinomial, and it's a y squared or an x squared on the first term, and the middle one has that variable to the first power and a constant on the end. Now, notice what looks a little different on 8, 9, and 10. How many terms do you see there? Only 2. So we're not going to use the AC method here. We're going to have another type of factoring, and this is explained on that first sheet in your packet that talks about steps of how to factor. You still want to look for a common factor. Doesn't matter how many terms you have. So 4t squared plus 1. Do I have a common factor other than 1? No, if one of the terms is just the number 1, there's no way I get a common factor of anything other than 1. Now, if you look at that list, there are 3 questions it tells you to ask yourself if you're trying to factor a binomial, 2 terms. Okay, so here's question number 1. Look at your first term. Is that a perfect square? In other words, can I take the square root of it and come up with something that is even? Everything comes out of the square root. Yeah, the square root of 4t squared would be what? 2t. So first term is a perfect square. That's yes to question 1. Question 2, is the second term a perfect square? Can I do the square root of 1? Is there some number times itself that equals 1? 1, right? Isn't 1 times 1, 1? 1's a perfect square. So I got a yes on question 2. What is question 3? If you're looking at your packet, what's the third thing you got to check? On the very last page for the problem, but you got to back up a page or 2 to where it says steps for factoring. It's not the, is the sign in the middle a minus sign, subtraction, or a negative? However you want to think about it. Look at the sign that's in the middle. Is that a subtraction sign? No, because I don't get a yes on question 3. What does that mean? This thing is prime or not factorable. I have to get a yes to all 3 questions in order for this thing to factor. And if I do get a yes, there's a little pattern that we follow on the factoring, okay? But you got to make sure you know those are the 3 things I've got to check. Is the first term a perfect square? Is the last term a perfect square? Is the sign in the middle negative? Excuse me. And if I can get a yes on all 3 of those, it'll factor. If I get a no at any of the questions, I stop and say prime, not factorable. Okay, so look at number 9. How many terms do you see? 2. Do we have a GCF other than 1? No. So I think I'm ready to ask the 3 questions. Look at the first term. Is that thing a perfect square? Yeah, I can take the square root of 36x squared and get 6x, right? Is the last term a perfect square? Yes. Square root of y squared is what? Y. Is the sign in the middle negative? I got a yes to all 3. So should this be factorable? Yes. And here is all you have to do if you get a yes to those 3 questions. Open up 2 sets of parentheses. This is still going to factor like backwards FOIL, but here's the pattern.
Oh, isn't it like it'd be 6x plus y and 6x minus 1?
You got it. That's exactly right. We're going to take the square root of the first term, which you said was 6x. That goes in the front of each parentheses. So 6x, 6x. We're going to take the square root of the last term, which you said was y. We're going to put that at the end of both parentheses. And 1 gets a plus and 1 gets a minus, and you are done. Because what happens if you use FOIL with this? Think about it.
It's like 6.
If I do outer times outer, what's 6x times negative y? Here, let me show you with the box. If we do 6x plus y times 6x minus y, 6x times 6x is 36x squared. But what is 6x times negative y? Negative 6xy. Positive times negative is a negative. So I get a negative 6xy. What is positive y times 6y? Positive 6xy. And then positive y times negative y is negative y squared. And what would happen when I try to combine these 2 like terms? They cancel. That's what happens. We call this a difference of squares. Difference means you're subtracting, and these are both perfect squares. And when you have that, it factors into the square root of the first term at the beginning of each parenthesis, square root of the last term at the end, but one gets a plus and one gets a minus so that these middle terms would cancel out when you use FOIL. All right? Let's see if we can do number 10. So you guys tell me, what's the first thing we should always look for? Do we start by looking to see if we've got perfect square? Be careful. No matter how many terms you have, what should you always look for first? Greatest common factor, because if I try to go straight to, is that a perfect square, I'm going to get a no. But instead, if I look first and I say, do I have any common factors? What are you going to say? Yes, these are both even numbers. 18 and 8 are even. So can I factor out a 2? And then what would go inside my parentheses? 9m to the 4th. And then what? Minus 4n squared. We're in agreement on that. Okay. Now, check what's inside the parentheses, and we'll see if it will factor more. Ask yourself the 3 questions. What's the first question? Is first term a perfect square? Is it? Yes, I can take the square root of 9m to the 4th. What's the second question? Is the last term a perfect square? The answer is yes, because I can take the square root of 4n squared. And what's the third question? Is it a subtraction in the middle? And the answer is yes. See if you can tell me then what you would put inside the parentheses. What's the square root of 9m to the 4th? 3m what? Squared. Good. So 3m squared here, 3m squared here. Then what? Good. The square root of 4n squared is 2n. So I'm going to put a plus 2n in one parenthesis. And what goes in the other one? Minus 2n. Excellent. Don't forget to bring down that common factor of 2 that we factored out in the very first step. So now we have finished our review notes on factoring. Okay, so let's go into our packet on chapter 1 notes, and we're up to section 4, quadratic equations. So what this means is now anything that's in that 1.4 review homework, you're able to do because we've covered all those examples. And we're going to start applying these factoring techniques into solving some equations. And the equations we're going to be solving are quadratic equations. Now, do you remember I've told you what would make an equation quadratic? What would you see in the equation that would make it quadratic as opposed to being linear? If it's linear, will I have any exponents in my equation? No. Linear does not have any, in fact, kind of keep this in mind. If I'm working with an equation and it's linear, it means I do not have any exponents on any variables. And I do not have any variables in the denominator of a fraction. We did have some with fractions, but the only thing in the denominator was numbers. And that's okay. That still is a linear equation. And the third thing is you would not see any special symbols around your variables. So I wouldn't see variables underneath a square root sign, or I wouldn't see variables inside absolute bars. So as long as I can get a yes to those 3 questions, that's how I know something is linear. If something is quadratic, this is what you have as your standard form for a quadratic equation. You're going to see an x squared or a variable squared, and that's going to be the biggest exponent. And as long as it could be written in ax squared plus bx plus c equals 0 form, then you've got a quadratic equation. Now there's a couple of rules about this. Do you know what the A, the B, and the C stand for? I mean, think about it. We've already been using the AC method for factoring. What are those A's, B's, and C's? They're just numbers, exactly. They're called constants or coefficients. They're the numbers that would be in front of the variables. So here are the rules. It tells us A, B, and C are real numbers, but it says A cannot equal 0. Now, it's okay if the C is 0. So in other words, if I don't see anything but a number x squared plus some number x, that's okay. It's still quadratic. I might not see the x, but I'll see the x squared term and I might have another number in there. Why do you think A can't be 0? Exactly. If A is 0, there's no x squared term, and that means it's not quadratic. So if it's quadratic, you have to have the x squared term, which means that you have to have some number other than 0 in front of the x squared, okay? So if we're going to solve quadratic equations, we've got some methods to use. Linear was real easy. We just wanted to get our variables on one side, we wanted to get the number on the other, and then we could solve for x until we got to where it said x equals. Quadratic is not that way because is an x squared and an x, are they like terms? Can I combine them to be one term? No, because remember, like terms have to have the same variable raised to the same exponent. So I can't solve it that way. Here's why we learned how to factor. We can use, not all the time, but sometimes, the zero factor property to solve quadratic equations. And what that means is simply this. Remember when we factored, most of the time we got a parentheses times a parentheses? Like if we were doing the AC method, that's what we ended up with. All right, so if I have this thing in standard form, and I can factor this, and I get a parentheses times a parentheses. They're just using an A and a B to represent the parentheses. Think about it for a minute. If something times something equals 0, do I know what one of those would have to be? One of them would have to be 0. So either my first parentheses, which we'll call A, would be equal to 0, or my second parentheses, which we'll call B, would be equal to 0, or it could be both are equal to 0. Okay, so all we're going to do is practice making sure we have a quadratic equation. We put it into standard form, which means we get everything on one side, set it equal to 0, and then we're going to check and see if it's possible to factor it. And then once we get it factored, we just have this one extra step. We'll set each factor equal to 0 to see if we can figure out what values for x would make this true. So what did we say is the very first thing? If we look at this and this is quadratic, make sure the equation is set equal to what? 0. Excellent. Okay, is this one already set equal to 0? Good job. So now I'm going to factor. Or at least I'm going to try to. So I'm looking at this, and I don't want to lose the equals 0, but I'm really just working with what's on the left side now. So I'm going to look at that 10x squared plus x minus 2, and I'm going to think, how would I factor that? And what would you say we need to pay attention to? What would you check for first? Greatest common factor. Is there a GCF other than 1? No. So what method would I probably need to try to use here? AC method. So talk to me about what's your A, what's your C? A is 10. C is -2, right? Because the sign in front of a number stays with the number. So what does A times C equal? A -20. Okay, right there. What does that tell you about signs? Say again? Different signs. If I multiply two numbers and I get a negative, I had to have a negative times a positive. Okay? What else do I want to write down and use to help me to figure out the numbers? B. And what did B equal? Yeah, it's going to be whatever the number is in front of the x. I don't see one. What is it? +1. So if I'm adding two numbers and I get +1, but I multiply these two numbers and I get -20, What pair of numbers do I need? I got one suggestion here, 5 and 4. I know the only things I can multiply to get 20 are 1 and 20, 2 and 10, and 4 and 5. And if one's positive and one's negative, remember our rule says what we really do is subtract the numbers, and then we'll keep the sign of the larger number for our answer. So which one needs to be negative, the 5 or the 4? The 4 is negative and the 5 is positive. So when I add those, I get positive 1. In agreement on that? Okay, and if I double check, multiplies that together, I get negative 20. Add that, I get positive 1. Okay, we still haven't factored yet. We just found the pair we think we need to be able to factor. So what do I need to do with that? Plug it in for B. So I'm going to come over here and I'm going to write 10x squared, and then what's going to go in place of plus x? Minus 4x plus 5x minus 2, and then don't forget your equals 0. Keep it there. We're not really using it right now, but you don't want to lose it. Okay, now what? Say again? Okay, and I'm factoring by looking at how many terms now? Just 2, the first 2. And what would be my GCF? 2x can come out. So if I factor out a 2x, tell me what I would have inside parentheses. 5x, because 2x times 5x is 10x squared. Then what? Minus 2. Do we all feel pretty good about that? All right, now what do I do? Bring down the plus sign. And I've got to look at the second pair. Now, what would be the GCF on that? Good. Do I need to write it down? The answer is yes, because if you don't, you're going to forget. Okay, my GCF is 1, and that means inside the parentheses, I have the 5x minus 2. Now, does that parentheses match the first one? Yes, that's a good thing. So you tell me what I'd put inside one of these parentheses. The 5x minus 2, because that's the new GCF. What goes inside the other one? 2x plus 1. Do you see why it's a good idea to write that 1 there? Because if you don't write it down, you're going to probably not realize you need to put 2x plus 1 inside the other parentheses. Okay, so when you're pulling out the GCF for a pair at a time, even if the GCF is 1, write it down. Okay, now I had finished factoring. So at this point, if that equals 0 had not been there, this is all we had done prior to this section in our homework or in our notes. But we've got one more step to do, because now I have a parentheses times a parentheses equals 0. How am I going to figure out how to solve this? The only way that's true is if what? Either one or both of those parentheses equals 0. So we're going to set each parentheses, or you could put each factor, but ours are inside parentheses, equal to 0, and then solve. So that means either 5x minus 2 equals 0, or 2x plus 1 equals 0. Are those pretty easy to solve? I think they are. What would you do to solve for x in this first one? Add 2 to both sides. Good, because remember, we're trying to get the x by itself. And you have 5x equals 2. So then what do you do to finish solving for x? Divide both sides by 5. And that would mean that x could equal 2/5. Or let's come over here. What could I do to solve this one? Subtract the 1. And that means that 2x could equal -1. To finish solving for x, you have to do what to both sides? Divide by 2. So what is the other possibility? X could be, and it's negative, right? These are my 2 possible solutions for that quadratic equation. The only time the left side will equal the right is if I let x be 2/5 or I let x be a -1/2. Does that make sense? All right, so adding on the extra step of making sure the whole thing equals 0 in the beginning and then setting each parentheses equal to 0 at the end. Does that sound pretty doable? All right, so here's a quick question for you. Do you think, as long as we've got something that's quadratic, we can always solve it this way?
No, because you said no.
Okay, so Patrick remembers I said no. Remember when we started factoring, what happened sometimes if we were looking for, say, a number that the a times c was equal to 5, but b was equal to -3? Is there anything you can multiply to get 5, add to get -3? No. So sometimes when we tried to factor, what did we have to put down? Prime or not factorable, right? So if not everything can be factored, that means not every quadratic equation can be solved by factoring. Does that make sense? If it can be factored, this is probably your faster, easier way to get there. But it's not going to work all the time. It only works for quadratic equations that can be factored. So far, so good? Okay, so let me teach you one more method that we can use to solve certain quadratic equations. I'll tell you, this one doesn't work all the time either, but this is called the square root property. Now, think about this for a second. It says if you've got a number that you could square that's equal to, I don't know, whatever number you would come up with. And we'll look at this with some specific examples in a minute. So, in fact, let me do it this way. Let's say I ask you, what number can you square and the answer is 4? What are you going to tell me?
2.
You're going to tell me 2. And you know what? If you tell me that answer on your paper, you're only half right. Because what else could you square to get 4? -2. Because remember, there are how many roots for a square root? There's always 2, a positive and a negative, right? Now, we said if it comes to you with that square root sign already there, that's asking you for the positive root, right? But think about it this way. If it comes to you as some number squared is equal to this, you're the one putting the square root sign in to solve for it. And if you put the square root sign in, you've got to remember there's both a positive and a negative root. And that's what this is telling you. Whenever you come up with the square root of this number, remember there's the positive of that and the negative of that. You need to give both of those answers. So this is saying the solution set of this is a positive square root of k and a negative square root of k, which could be abbreviated this way. You can put a plus or minus sign in front of 1 square root of k, okay? So when you're writing this on your paper, it is perfectly okay to use the plus or minus sign, kind of a shortcut way of writing it. In the computer, you'll have to pay attention because sometimes it gives you those open braces like this, and it tells you to separate answers with a comma. If that's the way they want it, you would write it out this way. If they give you the option to use a plus or minus button, then you could write it this way, okay? So let's look at this. Because the first thing I'm looking at is, would this thing be a quadratic equation? Yeah, why? Because there's an x squared in it, right? As long as it's got a variable squared, that makes it quadratic. But think about it this way. Is it in standard form? Remember what standard form looks like? Standard form is ax squared plus bx plus c equals 0. So is it in standard form? No. To get it in standard form, you'd have to get it equal to 0. Now, if I took this thing and I got it equal to 0, what would I have to do to both sides? Subtract 29. So if I end up with x squared and I want to move the 29, that would turn into a minus 29 over here equals 0, right? Now, if I write it in that form, can you tell me what's my A? 1. What's my B? 0. Why do I know B is 0? Because it doesn't have a term that just has a plain X in it, right? So if it's not there, it's because the B was 0. Does that make sense? And the C would be what? The negative 29 when I write it in standard form. Now, you're not going to put it in standard form, but I wanted you to see that B is equal to 0 because we don't have a term that has a plain X in it. And you can certainly see that here. I've got an X squared term and I've got just a real number. So I've got an A and I've got a C. There's no B. So the only time this method works is when B equals 0. All right? Don't use it unless B equals 0. All right? Now, when B equals 0, notice what it said. We're not going to put this one in standard form because there's an easy way to solve for x if I know x squared equals 29. What would I need to do to solve? I don't want to know what x squared is. I want to know what x is. So what would I do to get rid of a square? I'm going to have to take the square root of each side, right? So let's do this. I'm going to take the square root to get rid of the square that's on the x. But if I do that to the left side, I've also got to what? Do it to the right. And here's where you got to be really careful. This is the part that will get you. What do you need to put in front of that square root sign on the right? Excellent. Plus or minus, because there's both a positive and a negative root. And that will be the tricky part on this. It's very easy to forget that. So what's the square root of x squared? X. And then I'll just double check. Is 29 a perfect square? If I put it in the calculator, is square root of 29 going to give me a whole number, or is it going to give me nasty decimals? Nasty decimals. Is there any way that 29 might factor to where something could come out? What can you multiply together to get 29? 1 and 29. It's a prime number. I'm done. There's nothing else I could do with this.
So you're saying simplify it if it needs to.
Simplify it if your radical can be simplified. Now, and keep in mind, anytime you've got an answer that it has the radical in it, unless it tells you round your answer to the nearest whatever, you're going to want to leave it in simplified radical form. So don't try to give me some decimal number for this. Unless it said round your answer to the nearest whatever, okay? You're going to leave it as plus or minus square root of 29. And that's it. You're done. It's an easy method, right? But it doesn't work all the time. You can only use it when? If the B equals 0. Good job. Okay, so let's look at the next one. I've got x squared equals negative 144. All right, talk to me about what you know on this one. Is it quadratic?
Yes.
Yes. Do we have any common factors other than 1? No. And what is your B value? 0. So does that mean I can use the square root method? Yeah. So if I write x squared equals negative 144, what am I going to want to do in the next step? Take the square root of each side. So if I take the square root on the left, I got to do the same thing on the right. Did I write this down correctly? Is there anything else I need to do? Plus or minus. Don't forget it. Okay. So the square root of x squared is what? X. Here's my plus or minus. Now, what am I going to do with that square root of negative 144? Excellent. If there's a negative under the square root sign, I've got to remember to take the I out. So that would be I, and then square root of 144. Now, what should I check about square root of 144? I need to see if it's a perfect square. If I don't know, stick it in your calculator. If you get a whole number, you're going to be done. 144 a perfect square? So what would my answer be? X equals, tell me what to write, plus or minus. It would be I times 12, and when we write it down, which part would we want to put first? The 12. X equals plus or minus 12i. Okay, give me a quick signal. Are we here, here, or here? All right, I'm seeing a number of thumbs up. That's good. All right, talk to me about what you notice on C. Anything a little bit funky or different on this? Tell me again. Yeah, it's not just X being squared. I've got a parentheses being squared. Yes. You don't have a chapter 1 packet? Is there anybody else that doesn't have a chapter 1 packet? Okay, so talk to me. You said we have a parentheses squared instead of an x squared, but is the x inside the parentheses? So would you agree that if we were able to get rid of the square, make it go away, we would then be able to get to the x? You know what I'm saying? All right, like on these others, we didn't have an x, we had an x squared, and we said I can get to the x if I can make the square go away, right? And that's why we took the square root of each side. So if I look at this one, I don't have just an x, but if I could make the square root go away, could I get to the x? You know what I'm saying? Because all I'd have left is x minus 8. And if I just have x minus 8, can I move the minus 8 if the parentheses and the square is gone? Yes, so even though it looks a little funny, we can actually use the same method here. Okay, so you said if I can get rid of the square by taking the square root of each side, this looks like a strategy that might work because it would get me to where I can get to the x. So the square root cancels out the square, and what am I going to have on the left? X minus 8. Good. Equals. Now I know I've got this plus or minus. What am I going to do with the square root of 24? That one I'm pretty sure will simplify. So if I put it in the calculator, 24 is not a perfect square, but I bet you've done this enough to know we get some factors that get repeated if we do prime factorization. What would you divide into 24 first? It's a prime number. 2, because it's even. Goes how many times? 12. Still even. So 2 goes how many times? Still even. So 2 goes how many times? 3. Okay, so I've gotten it factored. What am I looking for? Pairs. So 2 of it at a time. I've got a pair of 2s. So you tell me, how do I simplify the square root of 24? What comes out? Good. 1 from what I've circled, a 2 on the outside. What stays under the radical? Good. Multiply the 2 times 3 back together and I get 6. Y'all said that very confidently. I'm proud of you. Okay, we're really close. I don't have x equals. I have x minus 8 equals, but how can I get it to just say x equals? Add 8 to both sides. You're exactly right. And so here's what will happen. I have x on the left. Now, I've got 2 terms that I'm going to have over here on the right. One of them is a rational number. 8 could be written as a fraction if I put it over 1. The other one is irrational. So just like we said with complex numbers, we put the real part first and the imaginary part second. If you have rational and irrational, you put the rational part first and the irrational part second. And so what this means is that x can equal 8 plus 2 square root of 6, comma, and x can equal 8 minus 2 square root of 6. If I needed that decimal approximation, I'd have to put it in the calculator this way. I'd put it in one time with a plus sign, get that number, and then I could come back a second time and put it in with a minus sign and get that number. Make sense? Okay, so we have covered now how to solve quadratic equations with two different methods. One is factoring, and that's why we practiced the factoring last week and then again at the beginning of class today, because when we can factor, that's usually a pretty quick way to solve. But does everything factor? No, every quadratic equation will not factor. Sometimes it's not factorable. So we got to have another strategy. This is strategy 2, and we use it either when the b equals 0, or we see that the only place we have an x is in a parentheses with a square on it, and then we can take the square root of each side. And we call that the square root method. And when they're quadratic, what have you noticed as far as if we were factoring, how many solutions did we come up with? X could be two different things, either this fraction or this fraction. If we were using the square root method, how many different answers or solutions are we coming up with? 2, because we have the plus or the minus. Remember when it was linear and all we had were x's? We got x equals a single number, or we had those special cases when it was either an identity or a contradiction. And that meant it was either all real numbers or it was no solution. That's when it's linear. When it is quadratic, you will probably come up with 2 possible solutions. But again, this has limited times we can use this method. We haven't found one that we can use all the time yet. So I'm debating on whether to go ahead and start on this or not. How many of you guys remember something called the quadratic equation formula? Okay, the name is probably familiar. How many of you had a teacher who said, you need to memorize this? Okay, 1, 2. Do you still remember it by heart?
I did a square.
You're thinking of Pythagorean theorem. We are going to talk about that one too. Here's the quadratic equation formula. Okay, now we're going to end the notes with this. We probably won't have time to get through it, but I'm going to go ahead. In fact, Bryce, would you do me a big favor and close the door? Okay, because I'm about to humiliate myself. And other than whatever I do with this video, I don't want you to put this on YouTube, okay? Or post it somewhere that will terribly embarrass me. But you do need to learn the quadratic equation formula, okay? It will be helpful. So I have a little ditty I am going to teach you. I know, moan and groan. And I will tell you guys, I have done this in the past with football players, and I promise they sang it too. So you're not exempt just because you're a football player. This will help you remember it. Now, I apologize. How many of you had a teacher that kind of did the Pop Goes the Weasel song? Y'all heard that one? Okay. I mean, that's really, really old. This is almost as old. I need to find something to update it even more, but it's a little newer than the Pop Goes the Weasel. And I'll tell you, after we start singing it in class, there's going to be times you're going to lie down at night and you're going to be cursing me because this little song's going to be running through your head. But that's a good thing because then you'll know it when you take your test. Are you ready? Okay. Remember the old Addams Family TV show? Da-da-da-da. Da-da-da-da, 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 da-da-da-da. It's not creepy or spooky, certainly not kooky, maybe a little kooky. The quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. Everybody, negative b. Come on, plus or minus the square root of b squared minus 4ac over 2a. Snap, snap. All right, so we are going to be practicing this so that you will learn it. All right, and I will tell you, I have watched students when they take their test, they will write, snap, snap, write, snap, snap until they get it down. Okay. So you don't have to learn the little parts in the beginning, but we're gonna see if we can sing this part together. You ready? So da 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 da. What is it? Negative b plus or minus the square root of b squared minus 4ac over 2a. Do it again. Negative b plus or minus the square root of b squared minus 4ac over 2a. You got the lyrics right here, okay? I promise. Yes, as you practice.
I just know it.
You just know it. See, if you already just know it, you're good. But if you didn't know it, you've got a tool to help you remember it now. And here's the cool thing about the quadratic equation formula. So far we said, will factoring work all the time?
Nope.
Nope. Will square root property work all the time?
Nope.
Nope. But guess what? Quadratic equation formula will work all the time. So if you only know one method, this needs to be the one you invest in. However, I'm going to tell you when we take our next test, I'm going to give you one problem that will say you need to solve by factoring. One problem that will say you need to solve using the square root method. And then one problem that will say you need to solve using the quadratic equation formula. Now, if the only thing you know is the quadratic equation formula, you can use it on all three. What's going to happen is you just won't get full credit on those first two because you used a different method than the one I asked for, but you would still get some credit for knowing how to get the answer. You know what I'm saying? After we get past this first test, you can use whatever method you want for solving a quadratic equation from then on. But I'll tell you, I think factoring is a lot faster and easier when you know how to factor. Okay, so we'll do one of these as an example, and then we're going to head to the lab in just a little bit, but I want you to see how this is going to work, okay? So to use the quadratic equation formula, here is, first of all, is that a quadratic equation?
Sure.
Yes, it is, and I know that why? It's got an x squared in it, and so I need to solve it. Now, just out of curiosity, is our b equal to 0 on this one? No, we have a b value that's not 0. So what that tells me is I couldn't try to do that square root method anyway. And if I'm not using the square root method, this thing should be set equal to what? 0, exactly. Set the equation equal to 0 before you identify a, b, and c. Even if I was going to factor, I still have to be sure this is set equal to 0. So what am I going to have to change if I want to set this equal to 0? I got to move the 3. So I'm going to subtract 3 from each side. So that's x squared plus 6x minus 3 equals 0, right? Because I'm subtracting 3 from each side. So far, are we good? Okay, so you tell me, what is my a? 1. What's my b? Positive 6. What's my c? A negative 3. Now, just out of curiosity, if it hadn't said that I had to use the quadratic equation formula, let's just see if this thing would factor. What is a times c? A times c is 1 times negative 3. So that's a negative 3. So I need a pair of numbers that would multiply to negative 3, right? What's the b? A positive 6. Okay, is there a pair of numbers you could multiply to get negative 3 and have to get positive 6?
Probably not. Negative 2.
Well, now remember, I need 2 numbers. If I'm multiplying and my answer is negative, what do I know about the signs? They're going to be different. So 1 negative and 1 positive. What are the only 2 numbers I could multiply to get 3? 3 and 1. 1 times 3 is the only way I'm going to get 3. It doesn't matter if I put 1 here, 3 here, 3 here, 1 here. Is there any way that adds up to give me 6? That tells me this thing wouldn't have factored. Okay? So I wouldn't have had any way to solve this unless I know the quadratic equation formula, okay? So we have now found a, b, and c, and we're going to substitute those values into our quadratic equation formula. And here's what we're going to do. You're going to write down that formula before you do any substituting. And to write down the formula, you're going to need to sing the song. All right, you ready? Da-da-da-da. 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 Da, 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 da. I'll slow it down and sing with me. Negative b plus or minus, sing with me, the square root of b squared minus 4ac over 2a. Snap, snap. Okay. You gotta get the formula right. You can't get the answer right. You gotta be able to have the right formula to plug in. So what do you think we need to do now? We wrote down the formula. So now we need to plug in the values for A, B, and C. What have I told you is always a good idea before you write those numbers down? Remember? If I'm going to have to substitute in a bunch of numbers for these letters, what should I put? How about a parentheses? Remember, if I will put an open parentheses before I put in a number, that helps me not make sign mistakes as easily. And I will tell you, oops, I don't want an A there. I want a parentheses and a parentheses. And I will tell you the easiest place to make a mistake on this is to think I've taken care of this negative sign if my B happens to be negative already. So if you'll do the negative and put a parentheses, then all you're doing is putting the actual values in those. So what goes in for B? 6. Here's another B. So 6 goes there. What goes in for A? 1. C is a -3, and that's an A, so that's 1. That's what I would do. Put a parentheses where those variables were. Then you can plug those values in. So that's actually what we've done now in step 2. What do you think needs to happen now that we have numbers in there? We're going to simplify this, right? Or we're going to have to come up with something that we can work with. But when it's sort of a mess like that, where we've got all these parentheses and exponents and the square root sign and all that stuff, where do you think we want to start our simplifying?
In the square root.
Very good. It's called the radicand, the part that's underneath the radical. Okay, and I'm going to give you a word here because we're going to use it again next class. That b squared minus 4ac is called the discriminant because that, oops, discriminant, because that number that shows up underneath the square root, we can know some things about the type of solution we're going to have. So we'll focus on it a little bit more next time. But that's the part I want to clean up first. So I've got the square root of 6 squared minus 4 times 1 times -3. So just looking at the part that's underneath the square root sign, what do I clean up first? Think order of operations. The 6 squared, because there's an exponent there. So I'm going to I'm just going to kind of draw a little arrow up here. And I want to figure out what that number is. So the 6 squared minus 4 times 1 times -3 is 36. And then what do I do with this? Minus 4 times 1 times -3. Is it -12? Or +12? Which is it? Because remember, if the sign in front of a number stays with it, this is like -4 times +1 times -3. I've got 2 negatives being multiplied together. That turns it into a positive. So what's the number that goes under the square root sign? 36 plus 12 is 48. There you go. So I have x equals -6 plus or minus the square root of 48 over what's in my denominator now. Okay, does that thing look a little bit familiar to you? You remember what we did at the end of section 1.3? We had things like that we talked about. How can you simplify that and clean it up? So how are we going to simplify our radical? We can first of all look at, can we pull anything out of the square root of 48, right? Simplify the radical, and then you're right, we're going to break it into two fractions. So if I took 48 and did my prime factorization, what goes into 48 evenly? 2 goes 24, and 2 goes into 24, 12, and 2 goes into 12, 6, and 2 goes into 6, 3. And what would I look for? What would I circle? Pairs. So I got how many pairs? Yeah, I got a pair of 2s here, and I've got another pair of 2s here. So you tell me what's going to come out from under that radical. I get a 4 on the outside. What stays underneath? The 3 I didn't circle up. And then, just like Patrick said, we can divide this into two fractions by putting the real number part, or I should say the rational number part and the irrational part over 2. You got a question, Derek?
So I keep forgetting. So you know how you circle the 2?
Uh-huh.
So it's how many 2s it is. That's what you put on the outside.
You take one from each group to come outside, and whatever comes outside gets multiplied together. So 2 times 2 is 4. Okay? So that's how we got the 4. And now see if you can clean this up for me. What is negative 6 divided by 2? Negative 3. Plus or minus. Can I do any simplifying with that radical? 4 square root of 3 over 2. Is that in simplest form, or can it reduce down? It can reduce down, because remember, if I have common factors on the numbers that are outside the radical, they reduce down. So 4 divided by 2 is what? Negative 3 plus or minus 2 square root of 3 is my answer. That's how many numbers or how many solutions? X is equal to that, but that's how many? Is that just one answer, or is that 2? 2, because I have what? Plus or minus. Very good. Very good. Okay, so have we kind of reached a point that you feel like your brain is full? I would imagine that you have. I've actually covered a little bit more.